Imagine spending months training an amazing machine learning model only to watch it fail when real users finally interact with it. This is something that happens to many companies, not because their model is bad, but because deploying and maintaining machine learning systems in the real world is far more complex than building them. Machine learning operations exist to bridge this gap. It ensures that machine learning models not only work in a laboratory environment, but continue delivering accurate, reliable results in real life. In this video, you will discover how machine learning operations makes this possible, why it has become essential, and how it transforms the way businesses use machine learning at scale. Machine learning operations is a set of practices, tools, and processes designed to manage the full lifecycle of machine learning models. This includes development, testing, deployment, monitoring, updating, and retiring models in a controlled and efficient manner. Machine learning operations connects the work of data scientists who create models with engineers and operations teams who manage live systems. Instead of treating machine learning as a one-time task, machine learning operations treats it as a continuous cycle where models must be maintained, improved, and monitored. This approach makes machine learning systems reliable, repeatable, and scalable within real production environments. Machine learning models rarely fail because of algorithms. They fail because of the environment around them. Data changes, user behavior evolves, infrastructure scales up and down, and business rules shift. Machine learning operations makes models adaptable to these real-world changes. It standardizes workflows, improves collaboration among teams, automates repetitive tasks, reduces errors, and ensures models stay accurate over time. Without machine learning operations, organizations end up with fragile models that perform well only in development but collapse under real usage. Machine learning operations manages the entire life cycle of machine learning systems. This life cycle begins with data collection and preparation, then continues into model training and validation. After the model is deployed, machine learning operations handles monitoring, quality checks, scaling, retraining, version control, and eventual decommissioning. Instead of treating each phase separately, machine learning operations integrates them into one seamless flow. This reduces delays, prevents miscommunication, and ensures that each step supports the next in a predictable and measurable manner. Data is the foundation of every machine learning model. Machine learning operations places strong emphasis on building automated data pipelines that clean, transform, validate, and store data before it reaches the model. If the input data becomes unreliable, the model will also become unreliable. By maintaining structured and monitored data pipelines, machine learning operations ensures that models always receive high-quality, consistent information, reducing failures caused by unexpected changes in data. Deploying a machine learning model is not as simple as uploading a file. The production environment must handle scaling, latency, hardware differences, and integration with existing systems. Machine learning operations provides automated deployment pipelines that test models, check compatibility, confirm performance, and then deploy in stages. This reduces risks such as sudden failures, unexpected errors, and performance bottlenecks. Deployment becomes repeatable instead of chaotic. Once a model is running in production, its performance can decline due to changes in data quality, user behavior, or external conditions. Machine learning operations solves this by tracking metrics such as prediction accuracy, latency, drift, errors, and system health. Monitoring dashboards and alerts notify teams when something goes wrong. Continuous observability helps organizations react immediately instead of discovering failures weeks later. This is one of the most important reasons machine learning operations is essential for long-term machine learning success. In traditional software engineering, version control ensures that teams can track changes, undo mistakes, and collaborate safely. Machine learning operations applies the same idea to models. Every model version is stored with its configuration, data sources, and training parameters. If something goes wrong, teams can return to a previous version or compare performance across versions. This makes experiments safer, reduces risk during updates, and brings structure to model management. Machine learning operations removes manual bottlenecks by automating repetitive tasks such as data validation, model training, testing, deployment, and monitoring. Automated workflows reduce human error and free teams to focus on improvement instead of maintenance. Automation creates consistency, allowing organizations to deploy models frequently without fear of breaking production systems. As time passes, models can become less accurate because the data they see begins to differ from the data they were trained on. This is called drift. Machine learning operations continuously checks for drift by comparing historical and current data patterns, as well as monitoring model predictions. When drift is detected, the system can trigger retraining, model selection, updating, or alert human teams. Without drift management, even the best models eventually become unreliable. A model that works well for 100 users may fail when 1 million users arrive. Machine learning operations ensures that machine learning systems scale efficiently. This includes managing compute resources, distributing workloads, load balancing, caching, and horizontal scaling. With proper machine learning operations practices, systems remain fast, reliable, and cost-efficient regardless of traffic demands. Machine learning operations brings together data scientists who focus on building models and engineers who focus on stability, security, and scalability. Without machine learning operations, these two teams often work in isolation, leading to conflict and confusion. Machine learning operations establishes shared tools, shared processes, and shared responsibilities. Everyone follows the same lifecycle, which reduces delays, improves clarity, and increases the overall success rate of machine learning project. Machine learning operations not only improves technical processes, but also creates measurable business value. It ensures faster releases, reduces model failures, improves user experiences, and cuts operational costs. Machine learning operations gives businesses confidence that their machine learning initiatives will remain stable in the long run. This leads to higher adoption, better decision-making, and long-term competitive advantage. Machine learning operations is the bridge that turns machine learning experiments into production-ready systems that truly help businesses and users. If you want to build reliable, high-performing machine learning products, machine learning operations is not optional. It is essential. If you enjoyed this explanation and want more videos on real-world artificial intelligence, production systems, and machine learning workflows, make sure to like, comment, and subscribe. Your support helps bring more clear, beginner-friendly explanations like this one.